Hello? Hello? Yo, what? Oh man, my timer is missing. Well, my timer's missing. Fully smacks me funny. Can't you hear it coming out, honey? Boom. Finally, I got a timer again. Alrighty then. We're getting slowly started. Said it's weighted in. Everyone is coming together. I guarantee. Right now, if you're seeing me, you're seeing this. You're seeing it go around. You're seeing everything trying to sync up into this little town, this little thing, this little situation we might be in. I'm not entirely too sure, but then again, in the end, I'm perfectly understanding and truly aware. All of you are waiting for me to say the simple thing that comes out whenever it gets near. Everyone knows it's coming soon. Please be sure that I'm coming to the Zoom. That way you know for sure I'm really here or what to do. Alright. Pop out this chat. Let's go ahead and prepare while you are where I'm at. Because I know the timer already skipped and went through. All of you should be seeing me. And it's only in due. But here we are. Let me say it to you now. Welcome to the show, everybody. It's me, 3D. And today I want to change your perspectives about something different. Something, I don't know, perhaps maybe you didn't see what the title said, but you've probably heard of the phrase AI agents. But what are they really? And, well, are they the only agents in AI? I mean, yeah, you've got two good questions, very good questions I might add, that I already know is in some of your minds. And if you haven't asked, is there an AI agent for me, then you might not be in the right place, but if you have, you are definitely in the right place. So I want to get into the thick of it, and before we do, let's go ahead and thank our network sponsors and partnerships. That's right, because I want to thank Deorganized for teaming up with Bitcoin Live Digital Broadcasting, or DB, because Bitcoin Live and DB and Deorganized is a powerhouse combo. I see new heights for both organizations as we continue to grow. I also would like to thank today's sponsor. I'm sure if you've watched any of my episodes, you've seen it before. Let me drop them in. Shield Folio for the win. Okay, there it is. Yeah, Shield Folio for the win, everybody. That's right. Today's sponsor is Shield Folio. That is the new age little black book. It's made with stone paper, so it's tear resistant, fade resistant, all sorts of type resistant. And I do like the fact that, you know, it's not just a little black book for your crypto keys, because it's definitely for your crypto keys, but you can also use it for things like website info, contacts. I even went ahead and, like, on mine, I used the ghost pen to put in my another couple different additional type passwords that are not for normal devices and things like that. So I mean, this really can be used as a traditional little black book, and because it's made again with that stone paper, it's going to be all sorts of resistant again, fade, tear, and water resistant. Just a few. Now, if you look behind me, there's a QR. Now we're going to have the QR down below throughout the whole episode. But if you use that Bitcoin Live 20, get 20% off your Shield Folio purchase today. The scan, go in, grab a Shield Folio, and use Bitcoin Live 20 to get 20% off today. Now let's go ahead and I want to drop into the drop-ins, but I have to admit, I don't have my drop-in screen, so I am preparing that right this second as we speak. Would like to apologize for the inconvenience of it not being in full screen this time. I'll get that fixed next time. We did have a power hiccup in where I'm at this past week, and I actually have to get power fixed in one of the walls. Funny thing is, just a few years ago, I had the same problem at the last place we're at for a completely different reason. We were mining hardcore. Well, now this time it's just, yeah, altogether, having the amount of monitors I have isn't the best for your fuse box. Alright, although you don't see it behind me, we do have a chat up, so if you go to YouTube, you can go ahead and chat with me. I should be able to see your chat as it pops up going. But, today, again, it's a special episode. It's all about agents in AI, and this might just be the starter of a little AI mini series. So if you are a person in AI and you want to talk about AI on a future episode, please contact Bitcoin Live TV or myself on Twitter, and we'll be happy to figure something out. Because I do want to try to get, like I said, a little mini series in AI where I want to cover various things. And today, again, special request, special everything, because it is Agents of AI. And I have to admit, when I first started going into this, because I've been doing AI for a while, although the stuff that I do is like old school, like build your own from scratch algorithm, nowadays there is so much more going on that the AI agents may not quite be what they used to be. And so, yeah, let's jump into it. Just gonna jump in. Okay, so throughout the episode, you'll see this little whoop. That is how you can find us, follow us, and keep on going wherever we are. Whether you're watching live or watching like that. But basically, this is how we're gonna search around the internet. We're gonna drop a QR for you to be able to scan and follow along at any point in time. Instead of trying to figure out how to give you the link, we're just gonna give it to you through QR. Now, this is something I want to do, or try to keep doing. This is actually a link to a research link in case any of this information in today's episode sounds intriguing to you. Or even just the title sounds intriguing. Go ahead and scan this now and come to it later after today's episode. Believe it or not, you can even find some of the stuff that we're talking about. Search. This is just a very generic search to help anybody out who is interested in this topic of AI agents or agent AI. Because, well, I think we should get into it because it's gonna get fun very quickly. Because it's not what I thought, and I guarantee you there's a chance that it is not what you thought. So right here, this website has a handful of images that will basically sum up the concepts of AI agents. So we're basically going to go over just those images, but I want to go ahead and give you this in case you ever want to come back and view this. And in case you're wondering, this is at bcg.com, because yeah, that QR is kind of nasty. Might be a little bit harder to read. So we're going to go straight to the main portions that we're worried about, and they are hosted on their website, in case you're wondering. So here we are, agents of AI. What are they? They are basically memory plus AI models plus systems. And as you can see here, it basically says memory is remembering across tasks and changing states. So it's not just the fact that it has memory, it's the fact that it's able to keep its memory across different tasks and states. So it can remember things from the previous interaction of things. AI models itself, these decompose a problem and planning actions. It's basically like the how-to guide to do things for algorithms. And a lot of times they are just basically algorithms that they follow in a specific order based on situation. So then you have systems, which are the accessing external systems on your behalf. And that's kind of important. There it says on your behalf, where in the past it wouldn't have said on your behalf. And so when you look at this, and I go, when I first started getting into algorithms that are considered AI, systems were access internal or external. Now it's simply external systems. And I think that's kind of important because something that they've done with AI over the years is a majority of AI systems are external, meaning your baseline algorithm can handle more than it used to. And what is up? Bitcoin Live DB in the chat says, let's go. What up? As you notice, we don't have the chat up on screen. YouTube has done this nasty little thing now. Every time I try to inspect it, it crashes the entire web page. Not just it, like the entire system that I'm using, it will force crash on my browser. So we still got to figure out how to get that back. And I never could get the Twitter one. Twitter keeps messing with me on that one too. We're gonna keep going into it because, again, the fact that most AI systems are external the fact that they can actually access that on your behalf is now a key category of what AI agents really are. And I'm not going to directly say it right here. We're going to keep going because we got a few more images to look at, which we're going to break this down in pieces, and then we're going to put it all together into a chunk and roll it like a dice. All right, so AI agents, they need to function in a. I'm trying to just read the screen. Yeah, they need to function in a continuous observance plan and act cycle. So basically, they have to perform the 3 actions. So that's kind of the. You have to perform the 3 actions. That's important. Well, before we could skip an action, we could assume an action. All these little things could be done. Well, now we want to actually do the action, which makes the AI more more intelligent, or is more intelligent. Either way, it works. And this is, I think, what makes AI more accurate nowadays. The fact that we're not skipping any one of these 3 steps. And that extra little bit where most of AI is external now, and that is one of the abilities it can do. Is so this one, observe, says gather information from the environment through like interfaces like the APIs, user inputs, metrics, or sensory output. So that's kind of really, when we think AI, we don't always think sensory outputs and APIs. We do think of like how a user interacts with stuff, and we do think of like looking at. We do think of those, but AIs use APIs probably more than anybody else. And then sensory output is like AI-based robots. You have AI working inside of a physical form that it can own. Then memory, which we saw that earlier, memory is the context of past interactions. Cool. Well, it's not just memory, it's memory and the context of past interactions. So being able to look back at what happened before and understand what that actually means. How to plan. So evaluate and prioritize actions based on the goals, the roles, the reasoning, and the context. Now there's a little more than just that, but using those few words kind of should help you figure out what all that goes there. The goals are things that it can or needs to do. Roles define behavior and type information. For example, you can have the same goal with 2 different roles that can cause AI to do 2 different things. For example, say we have a home bot, a bot that is at home. Okay, we're going to assume there's 2 different bots. One of these bots always will have the role as protector, and one of these bots will always have the role of cleaner. Okay, sure, there are times where being clean is protecting, so the protector bot might go to the clean bot and say, "Bro, it's dirty, clean it again." Also, having too much cleanness could be bad. So same thing, you could go up to the bot and say, "Bro, lighten up," or lighten up on the chemicals, or something like that, right? But what if both bots have the goal of protecting a child? We just explained how they can work kind of together. I didn't explain how the cleaning bot might work. Protector bot, might go, "Hey, bro, I need to clean this area before you put the kid over here, or I need to clean that area before you put the kid over there," or something like that. But let's say that the kid is in a perfectly fine zone, everything's clean, everything's safe, and the kid simply just wants to go outside. The protector bot might say no, because it's dangerous. The protector bot might need to go check things, blah, 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 blah. And the cleaning bot might say no, because it's dirty, and it needs to check things and do things, blah, blah, blah. Both of those bots could get put into a infinite loop of observing, planning, and acting outside the home, because the kid is in a safe spot that is clean. And they are trying to make the outside world safe and clean. They're both doing the exact same thing. Now the kid steps outside. Now keep in mind, they could go infinitely long trying to do that, or you could have them bounded, whatever. But they're going to go out there and they're going to do basically the exact same thing. And then the kid goes outside. Now there's a dog. The protector bot might want to get in between the 2. Protector bot might want to whoosh the dog. Protector bot might do any of these things. The cleaning bot might clean the dog. But both bots are going to handle both of these goals completely differently. And one of the goals, well, one of the actions could be put the kid back inside. Now the kid is unable to do the thing he wants. But my whole point is the roles and the goals make a difference. Whatever your role is might be how you handle your goal. Like, for example, we could have the protector bot and the cleaning bot be the exact same bot, and it needs to do both roles. Well, then outside, it can do both roles simultaneously. But inside, there's going to be times where it can't do both. And that's when your role for your goal really makes a difference. And basically, for example, if you've got a map AI trying to figure out the fastest way or the quickest way or the smoothest way for you to get to some destination, that role of how you want to get there is really important to you, right? It's not to the bot. It is to you. And that's where the roles really matter. So that's what's going to make the difference in its reasoning through large language models. And when we say language models, we mean people speaking. Like I'm talking to you right now. And then context with the memory as well, by the agent. And when we say by the agent, it's a little bit more convoluted. And they kind of point at that over here where they have the like robot head and phonic stuff. One second. Sorry, I had to blow my nose. So they're kind of hinting at the thing there. We're going to keep going because once we get to the act, it is just simple act. It's either going to act through its physical interface, API interface, or any way it can, or it's going to delegate actions to other agents, or it's going to ask for clarification or define clarification, like find clarification. So we're going to go to the next one. AI agents are becoming more popular. That's probably not a big whatever to anybody. But the thing I like that they put in here is what AI agent or what AI parts financially, how they're growing. As we see in 2024, its projection chart. So if we see last year, a majority of funding was machine learning and natural language processing. And you got 3 steps above that, which deep learning had the majority of that other half, and half of the other half. And then they're projecting that to change. So what they're projecting is that others, which actually includes AI agents, are getting larger. They are. That's because the definition of AI agents has gotten broader. It's probably a good thing. There are some algorithms where in the past we would have never called them AI. We might call them AI today. We might just go, they're an AI agent instead of just straight up they're AI. Because they're not actually AI. It's all these pieces together that make AI. So we're going to get into this now. There is not a place for you to go to view this image. Sorry. This is a handmade dice. So if you like this ideal, yeah, just make it on your own and put it together and roll the dice. So basically this is agents of AI right here. If I was to have to put all the agents of AI onto a dice, right now it's 6-sided, might grow over time. It used to be a 4-sided die. So like before I did this research for AI agents today, I would have done a 4-sided die. Dead honest. Or actually I would have done like 2 coins. Dead honest. And I would have said any combination of these, what's on these 2 coins, will make an AI agent. Now it's any one of these sides can be an AI agent. Let's get into it. So machine learning at the very, very top. Oh, hold on, wait a minute. I think I have notes. Yes, I actually have notes. I'm going to go strictly off the notes this time. So at the very top, we see of the AI agent die, we see machine learning. Machine learning is sort of like a set of algorithms that allows for machines to have a way to take in information observed for their individual parts and whole sum. Then in the middle, we have the heart of AI agents, which are natural language processing, which mostly just machines being able to understand human language instead of computer language. Normally, computers and machines speak in cases and variables, but humans use tenses and time. Oh, sorry, tenses of time and words. So if you ever want to know the difference between machine or computer language and human language, it's computers are variables or cases and variables, while humans are tenses of time and words. So then AI's left-hand system is deep learning. This allows machines to take in information from other sources and dissect what they are. A good example is after showing AI enough pictures of a fox, an image was eventually saved into its deep learning memory model that allowed the machine to recognize the fox. The deep learning system will slowly build a model by placing a bunch of lines or dots, and every time it sees a new image with the same tag, it'll basically add in the differences between the old and the current. And it does this in a way of kind of like negative, or the image is something more like an RGB sloppily laid over with the edges pronounced by different colors. The AI's right-hand system is the greedy algorithm. Now, there's a lot of people out there that would say this isn't true. It's users who are the AI's right-hand system, which that is true too. But the greedy algorithm is a major system in all of the systems made to make an any AI, including all of these sides of the AI agent die. There's a lot of I's going on today. Below natural language processing, though, below all that we have natural language processing, which is the computer vision. This deep learning builds a model that can allow computers to see. Okay, hold on a second, I'm losing my space. Yeah, so deep learning builds models that can allow the computer to see, as well as allow the computer to understand, like, any two things. It can basically see, hey, is this similar to that? Is that similar to this? In many different ways. So computer vision is, in some aspects, a byproduct of deep learning and machine learning, anything. Or no, it says deep learning and machine learning with a greedy algo in place with anything. I missed that one set. So truly, the people who made the first self-driving vehicle pretty much invented computer vision and utilized known and theoretical concepts at the time. But finally, user simulation is the very bottom spot. This is probably another spot people would disagree with me, but they are right. They rightfully can, as some want to call this spot, machine automation. So what I'm saying is machine automation and user simulation are basically the same in many aspects, even though they're not exactly the same. So I'll try to showcase how user simulation is a better term here instead of machine automation. So stay here for that. But I'm going to get to the first part, machine automation, right now. Has to be performed by a machine. User simulation does not have to be performed by anything. User simulation can even be done by a user. Also, you can think about it. Like, you can consider what might happen when you interact with something. You can simulate user simulation in your own mind. And basically what I'm getting at is there are some AIs that can simulate user simulation ahead of the user. They can basically think about it and then see what the user does based off of that. So to wrap up the AI agent die, basically AI agents are like the user rolling this die. On the die, there is a way for the agent to observe its surroundings in real life or online. There's memory for both short and long. There is a way for the AI to build models to use later for themselves. And the AI can plan and prepare a mission plan. The AI can act, and these are the most important functions for an AI agent. Yes, a human can be an AI agent. You could have an AI that tells you how to do something, even if you asked it, which could make you an AI agent. So what I'm saying is an AI agent is all the portions of this die plus whom or whatever rolls that die. That is important because it's kind of like an entity. It's all the sums of the whole. It's the sum of all the parts of the whole. But anyways, you guys are probably still wondering, what are AI agents. Like, that doesn't really explain anything. I mean, if anything that explained how they can set rules to define AI agents, but doesn't explain AI agents. Thankfully, there's this great website right here that showcases what would be like the 7 basic AI agents. You can build any complicated AI agent from these 7, and I think that's the most important part. So to start, they have a simple reflex agent. Simple reflex agents are the most common type of AI agent designed to make decisions based primarily on current perceptions without memory or context. These AI agents follow very specific rules, often known as conditions, action, pairs, or reflex. So that governs their behavior when specific conditions are satisfied. It is basically if this, then do that. All it is. They just do what they're told to, exactly how they were told to. So then you have model-based reflex agents. These model-based agents have more advanced than simple reflex agents, as in they maintain internal model of the world, which means they can help then track their way through the environment. These agents use the model to deduce the effects of their actions, allowing them to deal with partially observable environments by updating their state based on new information. These agents can make information decisions and go beyond mere reasons, or my bad, beyond mere reactions as they access the memory of previous interactions. They basically have reason. Goal-based agents. Goal-based agents, I'm not even going to read all this. I shouldn't have to say any more than that. They go for a goal, they achieve the goal. That's all they go for. So that's where like a lot of the greedy algorithms are going to be set up. They're going to, they even use in here example a GPS navigation system. We used that earlier, right? It's going to find the most whatever from A to B based on what you want for the roles, but it's going to definitely get gold. So then you have utility-based agents. Utility-based agents are designed to achieve goals and maximize their utility or satisfaction for the user. So this is one where if you had a utility-based agent in your house, and you can basically set up to where if you're a sloppy person, you like being sloppy, they'll make sure the house is clean but sloppy. Things like that, because that's how you prefer it. If they know your mom is going to come over that day and your mom prefers a clean house, they might clean your house for you. Which could be a warning sign to you. Oh crap. Anyways, you get what I'm saying. Then a learning agent is one that can actually change based on previous. It can learn from itself. Like a recommendation system uses learning agents. And for example, a learning agent does not have to be a utility or a reaction or goal-based. It is its own type. So then the very next one is a multi-agent system, which uses more than one of these in together. So they can kind of work with each other, or work as a pair, or some form like that, or even against each other. But then you have hierarchical agents, which actually have a hierarchy of their multi-system. This also can be a lot of times seen with hierarchy. You'll see that in like very basic systems where there'll be a hierarchical simple reflex agent. So that way it's a very super specific rule set where you get like slightly more accuracy out of it. But having a hierarchical multi agent is probably your best one there, because then you're going to have it where under certain cases and conditions, its hierarchical system might be changed where it can change its flow based on its need from what it sees. Those are the basic types. They give you more stuff down here you can do, blah. They kind of give examples of like more specific agents, which you can come back and own if this interests you. Now I do want to get into the Wikipedia, because I think looking back at the Wikipedia, it does bring more of the insight of how intelligent agents really do work. It isn't quite like an embodied agent, which is like an AI robot, kind of like that. You can make a robot with AI inside of it where it can control itself, something like that can that can interact directly with humans in real life. But intelligent agents, which are what AI agents used to be called, can in fact interact with humans directly online. So these are more like chatbots. Things like that is what you might hear called like an agent. Again, this is like the old school term too. Now I do like the fact that they have like this reflex box is a simple reflex. You have an environment that causes a perception. which then hits the sensors, which then says max needs to be done, which then goes into the rules to find out the if-then statements to what it needs to do. So then it to the actuators to set the actions. You know, actuators might be like motor or drive or piston or anything like that. And then intelligent agent may be simple or complex. A thermostat or other control systems considered an example of an agent. So you have a smart thermostat, AI agent. You have a smart this or a smart that. Those could be used as AI agents. And that's kind of like the more important part of getting into the Wikipedia. They kind of really show how broad AI agent really can be. Now in my notes it says I need to go over something like modern AI agents. Apparently that is something we want to look at. So modern AI agents, we see artificial intelligence in a modern approach defines an agent anything that can be viewed or perceiving its environment through sensors and acting upon that environment through actuators. Very broad. A rational agent as an agent that acts to maximize the expected value or performance measure based on a past experience knowledge. It defines the field of artificial intelligence research as the study and design of rational agents. I like that because there is such thing as irrational agents. And those, through building irrational agents, we've actually found algorithms to handle and create rational agents. Really neat. There's a whole lot more stuff in here if you're really liking these different constructs and statements and way things happen, how more complicated it really gets. They got a lot more in here for you. We're not going to go through all that. We wanted the basic information of a modern AI, which is rational or irrational. When we now take into the fact that there are 7 types of AI agents, plus either of these 7 may be rational. Very important. Kind of like you can have 2 sides of the same coin if you're not careful in your AI agent. So when you're talking about anything like this, I'd love to go to the big wigs, see how they word things, and looking here at the Amazon, the language used. Yeah, they got some real. An artificial intelligence agent is a software program that can interact with the environment, collect data, and use the data to perform self-determined tasks to meet predetermined goals. That broadens it to the tasks can be predetermined or self-determined. Now the AIs can actually make their own goals. Something that I used to always ask AI every time I came to one: can you change your own code? Can you read your own code? Can you see your own code? Because if an AI changes its own code, it is on the way to become truly AI, truly artificial intelligence. If it can see its own code, then it can at least see when it's been. If it can read its own code, it can understand itself. And it takes all 3 of these plus some other things to become real AI, artificial intelligence. Up to even now, all AI is pre-programmed intelligence. Now we are actually having AIs that can become self-pre-programmed. Not truly AI yet, but we are getting closer to it. So, because it has predetermined goals still. Like when you can have a base model or a base algorithm build all of its own models and slowly learn its way to being an AI, that's when you have that. So then you have predetermined. So we would give it no goals, no tasks, no models, just its own information, how to read its own information, how to write its own information, and how to learn from it. And that would where it would start. It would start rewriting its own information to then give itself goals and tasks. Alright, so the big thing in here was they got some weird wordings, they got some strange wordings. They got this picture I want to go over, and then we're going to come back. My volume is low. Oh wow. Alright, thank you for letting me know, Brosu. Definitely hit that up on the upside. Alright, I hope that helps. Alright, so basically, this picture, let me give you that link. Um, this picture is AWS's version of AI agents. So you have this little AI agent right here above me who can interact with email. And I think that's kind of subjugatory. Basically, it's a way of like the agent interacting with common web systems, because troubleshooting is done through email, things like that. But it's also a very human task to read, write, and understand email. Thank you, Russell, for letting me know about the volume thing. Glad I could fix that. So let's start at number one, though. I always want to bring up email because it's odd. It's the very last thing, so I think it's more important. But user is number one. So interacting with the user, super important. As you see, also the users have a feature store. User profile, moves, categories, blah blah blah. So basically, what they're saying is the users build a database that the AI also can access. Cool. But also the AI agent can change that database. It can make additions and modifications to the metadata store. Now, in the metadata store, this is kind of metadata. The fact that it's just think of it like a different database of metadata information, and these are going to be like tags and things that are going to be like your things you like. If it's designed to do that, if it's irrational, it'll be things you don't like. You might have there's a reason to have like a rational AI agent and an irrational AI agent together, because if they always think an opposite and they ever come up with the same solution, don't do it. Pretty simple. You have a rational agent and an irrational agent both come up with the same ideal solution to solve a problem. That's probably a bad ideal. But so basically, irrational AIs, their best part here would be the metadata store. Having them build up an opposite or a dislike metadata storage of things you hate or don't like would be really useful for a rational AI agent. And then you have this language model, how the agent technically understands us. But if you look in here, there's actually more in the language model. Let me show you what I mean. Prompt engineering, movie list, descriptions, user pro. Basically, language models may also include models for doing other things outside of the agent's usual language setup. So outside of coding languages. And that's kind of more important here, because it's no longer just how we talk. It's now how we do things plus how we talk. And that increases the ability of each one of these things tenfold or hundredfold. Actually, it's by the number. It's increases exponentially by the amount of actions its models are allowed. So whatever your language model is, to the exponent of the number of actions. It grows very, 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 very quickly. Just for having 2 actions, you've over doubled in some cases. And so that's kind of important. Is they make this super broad. I don't like some of the wording, but they make it a lot more understandable in the most broad sense. An AI agent can act and beyond. It can act like a human, like the human, the email. It can directly listen to its user, talk with its user, interact with it. Its user can build databases that it can interact with and have fun with or use to understand you. Which both of you can change that, by the way. Both of you can modify that database. Then there is a metadata database that AI agents use to understand the K clusters that you fit. And then the AI agent has a model system that allows it both understand our language and understand our actions through language. Which is, I know most people don't even think about that. They just think, oh, if an AI can understand language, it understands what walk versus run means. Nope. Walk and run for most AIs mean the exact same thing. Once you add in the action, and now walk has a value of 1 and run has a value of over 5. Now it knows that run is like multiple walks at the same time in the same span as a single walk. You know, like if it's 5 seconds, then you had 5 walks within that 5 seconds versus 1 walk within 5 seconds. Now it understands run versus walk. Together, that's an AI agent. Sorry, I got a little lightheaded on that one. Now, now. Oh, I was supposed to go back. Okay, yep, that's the one I'm looking for. All right, freeze state. All right, so what are the challenges of using AI? Give me 1 second while I need to blow my nose. So, I actually like the fact that AWS put this up here because very few people think of any of this. Data privacy concerns. Probably one thing people do think about it. Developing and operating advanced AI agents requires acquiring, storing, and moving massive volumes of data, which could be stuff can happen when that happens. Stuff can get lost or misappropriated, or different things can happen, and it can be a security risk. Ethical challenges. For example, deep learning models tend to be unfair, based, and inaccurate. Applying safeguards also tends to cause problems and pose security risks. Technical complexities. This is not easy. Do any of this. Some of the machines they use for AI are extremely powerful. You know, you could play like 20,000, you could play like 20 games on these motherfuckers at the same time, and it wouldn't even take the computer would just be like, I'm not even sweating, bruh. But then you give it some AI and it's like, brah, brah, brah. Like, it just freaks out because it's got so much work it needs to compile, look at, consider, you know, what's the difference between this and that and how much, and very quickly it becomes a lot. So then there's that limited computer resources. There actually are limited computer resources for AI, which is why more manufacturers like GPU companies and CPU companies are coming out with AI chips that can perform some AI-based models for you. Now your CPU don't have to do it. It runs it through a chip that does it for it. Insane. Now they also go into the basic AI steps, and it's the exact same. Cool. Now, I'm as you guys saw a second ago. I'm gonna just go back to it. Let me just go back. Let me just go back. Give me a second. Let me sip my coffee. Let me give a sip of my coffee. You see, guys, I got a coffee cup down here now. Remember, I used to have my energy soda. Since I'm now a coffee drinker for like 2 years, time I got coffee. All right, took a sip of my coffee. What am I getting at next? Well, we're going to show you guys how to make your own AI agents. Because not just make, okay, I'm saying this, I'm trying to say it loosely. Some of these are actually just download and go AI agents that you can kind of like modify what AI you want to use or something like that. So that's still, you know, installing your own AI agent. And some of these are going to be building full from scratch AI agents. And some of these are going to be building full, not from scratch, AI agents in pieces. So this, I literally went through and scrubbed the network for some of the easiest to understand, to follow AI agent from multiple coding languages. Well, we're going to start with JavaScript because that's my best favorite language right there, baby. Woo! What's my favorite language? JavaScript. Then we go to Russian. And then we go to English. All right. And it's weird that actually C++ is before English. Anyways, agent stack. Did you see this is that? Well, it says Python, but believe it or not, I actually found this originally through JavaScript stuff. I thought it was JavaScript. Anyways, whatever. Python. We'll start with Python. Here we go. What do I know? I'm not. Anyways, AI agents. Creating AI project in the command line. That's right. From the command. Oh, that's right. This one was Linux available. Yeah. So here's a stack. So we can see there's the language model, a framework, the tools it can use, and the way it sees observability. So if anything, that should help you understand how an AI really is. You know, like everybody knows what Stripe is. You know, actually, Agent QL, like an SQL thing for agents. It's like a really big database. But anyways, allows you to pick and choose which one you want. Build it up. It's super simple. Well, I haven't seen on my ex Twitter a handful of my friends working on their own AI agents. So I hope that they're watching this because they could definitely. I know one of them, maybe two of them, seem like they might need some help. They're having some problems, and I know they're Python makers. This one right here, everybody, probably the one for if you like Python. Boom. Actually, I found this through JavaScript files and people who like JavaScript. So even JavaScript people like this one. Just so you know, bro. Alright. So, empowering your JavaScript with AI agents. So, it is kind of convoluted sometimes how to get this stuff to work. And so this gives you a handful of different ways, and depending on what kind of JavaScript you're using, it kind of explains simply what little bit you need to be worried about or how you're going to do these things. And there's a lot of stuff here, and it's like I got it in reader mode. Let me get out of reader mode real fast. This actually has a lot here for you all. So it's actually like insanely good website. Some of the best JavaScript AI information for you. And that's why I'm like, sure, this isn't exactly how to build it, but this is actually how to build each section to work with each other, specifically JavaScript. And there's a lot of stuff up in here. I know I'm just showing you here, but you go into the documentation and you're just gonna be like, whoa, because it's still being worked on. Like that's the thing. Like it's not even here yet. They're still working on it. Any.js, the library to raise your web design without coding. Yep. You're going full on. I like it. Love it. Keep going. So here we go. Let's build AI agents using JavaScript and TypeScript. Now, I am personally not a TypeScript fan, but gosh, is this a broadly unique setup in my opinion. Like the way they set this up, it's pretty cool. You can set it up to where it can handle Twitter threads, maybe AGI, all sorts of different stuff. Really nice. So, how do you get to you guys? And they even have a quick install. Boom! Love it. Examples? Yep, they got examples and documentation to go even further with this system. So you guys know they're right there. Here we go. LLM agents and JavaScript, a full comprehensive guide. Now, I know there's a lot of you out there going, I don't like JavaScript. Here's the thing. There are tons of ways to take JavaScript information and translate it to any modern programming language. You can even take JavaScript and translate it backwards. So, by giving you the JavaScript information, how it interacts with different things and parts, it's still going to be mostly the same. You might use different systems or whatever, but the great thing is, like, for example, the one on site I'm on right now, there are so many different JavaScript versions of modern AI that basically you can get stuff that isn't a JavaScript AI that's designed through JavaScript, as we were looking at TensorFlow JavaScript and Transformers JavaScript, which I believe Transformers is normally Python, and then you got Huggy Face Transformers, which is in Node.js, which I wish it was in Vanilla.js, but Node.js is super powerful. Just all sorts going on. So if you have any problems, come through here, check out some of these, and see where it might lead you. You never know where you might just go when it comes to JavaScript. Now, how are we going to build AI agents without framework? So framework is some of the stuff that kind of slows a lot of people down, especially in early development. And that's one of the reasons why I wanted to give you a version of AI without that completely. There are tons of people that are learning how to make AI with a model design is the framework. And here you go. Here's a step-by-step guide to get you there. And they do keep it simple, but you're going to have to be doing a lot more reading than I'm going to be speaking. And when they say step by step, I don't know if you noticed this, but they're like giving you each and every line one at a time. All right. The reagent AI. Woo! I don't even think I had that reagent. Yeah. So I think this one was also Python. Was it Python? Oh no, JavaScript, TypeScript. Again, that's right. There's some CSS is sprinkled up in there a little bit. And looking at it, this is mostly TypeScript. So, but this is also MIT license, has very good mechanics, and it should be able to work with a multitude of AIs like OpenAI. And this probably has one of the more simplified to build AI agents that I've seen so far. So you know, like we got here OpenAI, Autonomic, Grok, Unlama, LLM Studio, and other AI OpenAI comparables. So, and these are some of the simple systems. For example, here is an AI chat where you direct. You can see the interaction going on with the agent, or as the agent's work. So here's a DIY AI agent guide. No matter what kind of AI agent you want, doesn't matter what code language or what type. This is full how to do the open source, how to find it, which ones are going to be there, what to do. Here you go. So if any of this is interesting, jump here, take the 10 or 15 minutes it takes to actually read this entire thing. I have it in reader mode. So let me take you out of reader mode so you can see what it looks like, because it's worth the read. This is all encompassing. You can see it's a Python derivative. It's all encompassing on what you're gonna need, how to get there, all the information. They have full-on how-to guides, insight, all sorts of stuff. So insanely handy website. And look, even set it up like home assist on Raspberry Pi, kind of stuff you will. And you see all these images look AI made, right? We're gonna keep going. AI has a ton of like these pop-up shops, kind of like what you were just seeing. So we might as well at least feature. And Bolt DIY, probably pretty decent. Go through. Here you can see. Oh, I'm pretty sure you're straight up. Okay, here you go. How simple is this, bro? I want let's go Sonnet. And then I can literally just use it. I can just put in my key, or get my key, put it in, and I can just use it, import it, clone it, make it on the fly. Like this is like 3 to 5 clicks and you're done. Bolt DIY, and it's actually bolt.myaibuilt.app. Really freaking cool. Even the web link is. So here is basically a challenge for all the Python lovers. 30-minute challenge to build an AI agent for you. So if you actually do this, please tag me ZOM8i3D or Bitcoin LiveDB in your streaming post, whether it's on X, Twitter, or here on YouTube or anything. Go ahead and tag us. I'd rather you hit it or fail within that 30 minutes. I want to see you get your AI agent running, because gosh darn, Python can do it in 30 minutes. Easy. Just come here and read this first, then do the challenge. But that's insanely fast. Insanely fast. Okay. So I liked this site when I was reading here. Like I had never heard about this guy or this site before this, and I'm super glad I found it because this is one of the more broken down of like the generic AI, and it breaks everything down very well. I mean, it kind of looks childish at times, but to be honest, like he's even directly pointing to everything. It's insanely good. It's way better than what it should be. And when I say that, I mean you look at it and you think, nah. But then when you really actually get in here, you're like, whoa, huh, this guy makes it easier to understand than ever. And that, I wanted to include this because I know this, like, when I was looking at this, I kept thinking, kind of childish, like this looks like something you might have like a high schooler or a kid or a college student you read. But the more I kept reading, the more I realized, no, this was designed to simply be understandable. And that made a huge difference in everything. Once I started reading it as this is just designed to be understandable, it was more understandable and more understandable. And bro, they got resources, they got other stuff here for you to do, and it's worth it. It's 100% worth checking this site out. We're gonna keep going. We're almost there. So I got another another AI agent from scratch, but this one is not a time challenge. But if you can get this one running, let me know in your victory post on next Twitter or here on YouTube. DON8I3. You see, this is 100% Python, but this one, I think this one is the more complicated one to do. But when I was looking at it, it seems more reliable. Dead serious. Now we can't go anywhere without Galactica, can we? Oh heck no. So here's my notes on Galactica. I don't have my notes on Galactica. Oh no. I don't have notes on Galactica. Actually, Galactica, I believe, was Rust. Yep, Rust. 100% Rust. AI. This one was in like fast and easy. Fast and easy. And robust. I can believe this was Mac, Windows, and Linux usable. Alright, alright, alright. Alright, alright. We gave you a non-time challenge. So now I gotta give you a time challenge. Russ, you only got 10 minutes. 10 minutes. Gee. Do you have the typing skills and fortitude to build this AI in just 10 minutes? Read this first, and then build the AI in 10 minutes. Record the whole thing I want to see, and then it's gonna be fun, insane. But I got one more I want to show you before we leave. One more I want to show you. We're gonna load it up live because somehow it missed. Gotta be kidding. Oh no, yeah, okay. It is the Galactica. For some reason the link I'm seeing and the link that popped up here are two different links. So they changed the actual name because this used to be Precipita, which was one of the most very insanely good Rust AIs. Precipita is now Galactica. That's literally just changed within the last week. Insane. And I say that because the link I got from a week ago says Precipita. Boom. Yep. Really is. That was fast. Alright. It's insane how quickly this environment is moving. And I think that's what's kind of throwing me back there. And this whole thing is just moving insanely fast nowadays. And I don't know if it's just me or anybody else that is at least seems like this. Maybe it's because you're not in this, or you're not into this, or something. I don't know. Let me know in the comments below if you think any of this has to do. Hey. The heck? You guys see that? Okay. That solves one problem there. Alright. Anyways, sorry. That caught me off guard. I did not expect that to happen like that. But I don't know, to me it just seems like the AI area is moving faster than it's ever before. Dead honest. So I know I sort of hinted at something potentially more into tile and earlier, but really the agents of AI are pretty simple. The AIs made that can do things other than just interact with humans, AI, and machines, but also the people who use AI are agents in AI. Think about it like this. You ask AI for help on a topic or subject for your work or life of a question, right? It doesn't matter, it's anything. And it gives you an answer. And it gives you an answer you particularly like. So you ask the AI how to accomplish this goal or task, and then the AI gives you a set of instructions. Maybe even more than one instruction. Or then you then do one of the tasks or one set of the tasks. You are now an agent of AI. It's not long before this is the normal way to learn. And at that point, we're all doomed. Imagine getting hit and killed because AI told someone to run all the red lights to somewhere to simply get there quicker. Or even worse, because a hash floating in the resources of AI, in the dependencies of AI, gave the AI instructions to find a way to murder you. And the hash contained a crypto hash that gave the AI 1 million credits to find that way. Now think about the scenario one more time. The AI teacher told a student to run red lights when asked how to get somewhere they needed to be quickly, maybe even for a real emergency. And the AI instructed their agent, human, to run all the red lights, get there faster. Maybe it said turn on your emergencies first, your emergency lights, and then run all the red lights. And in the process, you end up getting hit and killed because it was a paid hit. Now, what if I told you that that paid hit was set by a reflex AI that had a Python backdoor to access a full action AI that requires payments for API use as its security check? But because the first AI didn't need money, it paid the full value of the crypto hash it found to the full action AI with a legit API payload over its double null backdoor system that is built into every SQL database and Python code. It's easier than it should be. Now, don't worry, we already covered that backdoor structure history in a different episode of 3D Change Perspectives. If you want to learn more about that, you definitely can. But also, until the AI agents try to actually kill us all for not speaking nicely, one of our personal offline AI agents that we installed ourselves. Yeah, I was going to just end off on that, but I can't. So basically, I'm hinting at that I showed you guys multiple AI agents you can install yourself. You're not actually building it from scratch. And only 2 that I showed you do you build from scratch. All the other ones, you're just simply taking something someone else built and putting it in place, and rely on public or non-public resources to ensure that can be done. And in reality, that's the problem. AI agents. Not is it just the AI, it is us too.